Okay then, next session. We're very pleased to welcome Matt Cosby from Goonhilly Earth Station. I think a source of a lot of inspiration for a lot of us who holiday down in the West Country, and I think a great marker for technology in the West Country as well on that side. And Matthew's here to actually share a request with us as well. So over to you, Matt.
Okay, thank you very much. So first of all, I'd like to thank AMSAT for giving me this opportunity, and I'd like to first apologise for this talk. I'm following Phil and Peter and great talks from this morning, and I'm going to be talking about standards, which I fully apologise. I'm going to have to give you an introduction to standards to give you the reason why I'm here and actually why I want your help. Phil, I'm sorry, picking on Phil, mentioned several standards like DVB, MPEG. So you use these standards all the time. You may not know that you're using them all the time, but there are teams of people that work on these standards that you actually use. And they are getting stretched, and this is why I want your help. So apologies. Okay, so what I'm going to do is I'm going to introduce myself first. Then I'm going to introduce the standards organization that I'm actually going to be talking about, of which I represent the UK Space Agency at, so does Phil. Talking about the standards that are going to be modified to support the moon exploration and Mars exploration. And then really I want to get into the detail about what I'd want you guys to help us with. And then I want to leave some time to actually, for you guys to ask questions and give me just feedback. So we've come up with ideas, and when I say we, it's institutions such as NASA, European Space Agency, UK Space Agency, and the French Space Agency. All these agencies have come up with an idea which we'd like to present to you, and we would like to get that feedback if it's a good idea or not. So I'm going to leave a bit of time to actually have that interaction. I'd really like that interaction and your feedback. Okay, so I introduced myself. So I am the UK delegate for what's called the IOAG, which is basically an organization that brings all space agencies together to make sure that they've got the recommendations and architectures to allow all spacecraft and ground stations to talk to each other. So NASA can talk to ESA, ESA can talk to NASA, commercial ground stations can talk to ESA, and so forth. I was also a previous chair of the Exploration Committee, which was also did a lot of work with Principia, so with Tim's flight to the space station. We did a lot of work with, obviously, with you guys from ARIS, but also AstroPi. So there's a lot of education that went into Tim's mission, which was sort of coordinated through a lot of the industry base. And my personal is that I've been working in sort of LEO, GEO, Mars, the Moon for about 30 years. I am also the Chief Technical Officer for Goonhilly, which is down in the most southerly part of the UK. It's on the Lizard Peninsula. As most people probably in this room have visited it. Most people come up to me and say, "Oh, as a kid, I was inspired by it for the visitor centre when it rains in Cornwall," which I have to say doesn't, as a sponsor by the Cornish Tourist Board, it doesn't rain at all in Cornwall, as never does. It's always sunny, so I don't know why people go. But on the off chance that it does rain, then people used to go to the visitor centre, which at some point we'll like to get open. I don't know if you can see, this is the operations centre that we have down in Cornwall, which is used to control the antennas. You can't just, but there's a reference there to Artemis 1, and we were preparing for Artemis 1, which I will go and talk to you about later. But also, we've expanded. Our main headquarters is in Cornwall in the UK, but we have 2 teleports in the US, one in Connecticut and one in California. And the reason being is that a lot of the work that we're doing, we split ourselves into 3 areas. National security, so looking for space situational awareness, space domain awareness, using passive and active RF to detect systems around in space. Also doing neighbourhood watch, so we look at high value assets such as the UK's military satellites, and then we can detect if things are around it. And having stations around the world expands that network, and we're currently working on that and hopefully have operational system in a few years' time. And then on the teleport side, having extension around the globe gives us more access to more geo slots. And from where I'm interested in, from the deep space side, we can try and use our large antennas to support the Moon, Mars, and so on going forward, as I mentioned earlier, and having a site in Connecticut and California, and then ultimately one in New Zealand or Australia gives us that full global coverage. The one in the one in California does have almost no rain. It is very sunny, so it's a perfect location for optical communications. So that's sort of an overview of Goonhilly, but also I'd like to just remind people about Goonhilly's involvement in AMSAT and amateur radio. We're a great supporter of what you guys are doing. We host multiple stations from, obviously Phil mentioned about Ham. I know I can hear you laughing, Noel. So. But does it? Excellent. Oh, if I'd have known that, I'd have put more pictures of him. Yeah, there's one. Well, obviously we worked. There was before COVID, I believe. Obviously, we were set up the station for Principia for Tim's missions for her first ham TV reception. We were the backup station for that particular mission, but it was great. Phil was talking about the hiss and the blue line, which is very disappointing to see that go, because that was actually a very good indication that we'd got it. Phil also mentioned about 60 centimeters on a tripod. This is not a tripod. This is Graham. He's holding us. He's doing a manual tracking of the space station using a 60 centimeter wok, and he got it more before we did on the 3.8 meter, but that's another story which I'm not going to mention. I did put your very first Azale 2, I believe, antenna as a picture. That's all right. Well, I thought that was my insurance, so you don't mention the 3.8. That's no longer there. You can ask Noel where it was, where it went, how long it lasted in the Cornish sunshine. And also, we were asked by the production team of the Great British Railways, because Michael Portello was coming down to Cornwall, and he wanted to come to visit us, and he said, "What can you do?" And I stupidly said, "Oh, we can bounce him off the moon." And then they said, "Oh, that's a great idea." And then phoned the AMSAT team, said, "I need to borrow you again to bounce Michael Portillo off the moon." There is a link to all our activities, and I think Phil's going to update it to include the one for 122, the 5 meter that he showed you. But yeah, please go and visit that to show all the stuff that we're doing and we're supporting. I'm saying that because I'm going to ask you for help. So just remember that in about half an hour when I ask for your help. Obviously, we were the first, of the UK ARIS team, were the first to receive the ham TV in, remind me, Rickmansworth, yes. After Tim, the previous night in the space station, spent probably about 3 hours looking for the cable and finally found the cable. Yeah, the reaction for most of the ARIS team of seeing the TV pictures come on the big screen was quite amazing. I think the actual grown-ups were screaming more than the kids. But that was great, yes, I know, yeah. But also, we continued working with, this is Thomas Piquet's ARIS connection down in Marseille, which we also supported, and obviously so we've supported not only the UK team, but also the French and European teams as well. So we're a great support, and we can't wait to see the contact with the Scouts in a couple of weeks' time. Next week. Okay, excellent. Right, but anyway, that was an introduction. That's not why I'm here. The reason why I'm here is I'm also the UK Space Agency's delegate for CCSDS, and I'm the Deputy Area Director of the Systems Engineering. Now, there's a lot of acronyms which I've just thrown in. Basically, I'm responsible, with my chair, with my area director, for the sort of combining all the systems that CCSDS create, which is the standards that spacecraft talk to each other and how they all fit together. And unfortunately, they don't really fit together very well, because we're traditionally point-to-point. So moving more to the higher layers in the network is a real problem. And that's going to become a problem later on with the Moon and Mars, because that's where we're trying to go to. So, bear with me before we go into the asking for help. I'm going to have to show you what we have to deal with. This is why I then need to go and ask you for help. So I'm going to explain what CCSDS is, explain why it's been noticed about what you're doing, and then what I want your help with. Okay, so CCSDS is an agency-led organisation. It does have industry partners. They are observer agencies. They contribute to the working groups. But basically, it is an ISO organisation, so it reports straight to ISO, and ISO publish these standards. But it is basically a space agency level members with quite a large number of associate members. So bear that in mind. But basically, these are working groups of about, I believe there's about, well, I've written it down somewhere, but anyways, 25 working groups that create standards throughout the life cycle of a spacecraft and a spacecraft mission. And I'm going to go through this now, which is why I need some water. Right. Okay. So this is, hopefully you'll see this, because I've stolen this directly from the CCSDS website, so it does have a bit of animation. But basically, what the CCSDS does is defines the end-to-end architecture. So it's not just about the ground station talking to the spacecraft. It's about the spacecraft talking all the way through the ground station, mission operations, and over to the MOC and to the payload and to the science users. It also includes mission operations, and it also includes scheduling and so forth. So it includes the whole section. So keep going through. So basically, we have the space. So what you get exposed to when you're building spacecraft is the onboard processes, onboard systems, and then you've got the link layer side itself. So those are the bits and the coding. So if you remember from Phil's presentation about DVB is also a standard that's based around CCSDS framing, fixed length frames. The ETSI have picked up the forward error correction that Phil mentioned, the Reed-Solomon and the convolutional. They're all CCSDS standards, and these all feed in to the ground station, and then so on to the mission operations center, and then to the user. And then the overarching is the systems engineering. Now, one thing that CCSDS is not very good at is bringing everything together. And bear that in mind when I, again, ask you for help. Right, I'll just jump over this one. But basically, the system engineer brings everything together. Then we've got the onboard services, as I mentioned, is all about spacecraft. And then you've got the mission operations, which try and standardize mission operations between agencies. And then you've got the link layer and then the networking side of it. And at the bottom, there's something we're trying to push forward, the Space Internet Working Services. And that is basically trying to replicate what we've done on the Earth, but doing around the Moon and then ultimately around Mars. And that's the thing that we've been pushing for over 20 years, and it's quite difficult to do because we don't really have this this sort of overarching systems engineering view. Okay, right, so ignore all the animation. So we have these working groups, who am I presenting? Right, we have all these working groups that feed in. And these working groups create recommendations. They create draft recommendations. They work for years to create documents that go through a massive series of processes. So they create a draft, then that goes through agency review. The agencies then comment on it and then pass it back to the working groups. And it goes through a huge cycle to get through. Hopefully this animates it. Okay. So this is a huge cycle that goes through the working groups, then goes through the engineering council, and then goes through the management council, and then goes around a lot of cycles. And once it's been ready for published, it then can go out to the missions straight away, and then also goes to ISO for where it's effectively adopted. So it is adopted by the heads of delegation, who are also the ISO people. So the ISO takes a bit of time, but the CCSDS documents can go to the missions quite quickly. Traditionally, and this is how it's currently done, is that the missions work with the working groups, so they get early access to the standards, so they can actually implement them while the standards are getting approved. because the process takes so long, that's what you need to do. If you've come up with a new mission, you want to try and get them adopting it as quickly as you can. And roughly a document that starts off being draft will take around about 5 years before it comes all the way through to be a published document. And one of my early starts in career was working on Mars Express, where we actually had a draft document for Proximity 1, which is currently the main workhorse around Mars. And actually the early spacecrafts fly the early draft because the document hadn't actually gone through the process. And one of the key things that to get the documents published, apart from going through agency review, is you have to demonstrate that it works. And the way that you have to demonstrate that it works is that you have to have 2 independent implementations of the document and then prove it through a demonstration interoperability test. And once that's passed, then it gets published. So this is where, bear that in mind, because this is what I'll be talking about later, which is what I want you to help. Okay, right. So what, I hear you say, this is all very dull. But this has enabled Goonhilly to be able to support all these missions. Without CCSDS, we were not able to support, we cannot talk the same language as these missions. We've had missions come to us where they haven't implemented CCSDS, and it's been very difficult for us to support. There was one mission where they'd actually implemented it at the wrong frequency, and we couldn't support it. So without following the standards, you actually lose the potential for actually getting support. And these are, if you are having a problem, now I think Peter mentioned EPIC, who have got Chimera, which was supposed to come around the moon, come back to GEO. They designed everything for GEO stations, but obviously it didn't come back, and it's now still going out. So I think it's about 20 million kilometers away at the moment, and you need the large antennas. And so you need to be able to speak the right language and the right standards. So I'll highlight a few of these. This is not completely up to date, but we've got intuitive machines, which we supported for the very first commercial lander on the moon. We were the prime station. We got their signal back. They'd fallen over, so they were not in an optimum communications position, which is a slight understatement. And we had to do some very clever bits of engineering, nudging the dish around, trying to lower the noise floor to get the signal back. But we actually got the signal back to them. We detected their signal, and we actually told them they'd landed. They had landed. They just fell over. So that's because they were using AOS, which is one of the standard protocols. We could see that, but we were already under contract with them, so it's part of our normal operations. Intuitive machines too. Again, they fell over. Well, they didn't fall over. They gouged a length of the moon, which was actually very good for their payload because they managed to get some of the regolith into their missions, which was very good into their payload. Sorry, into one of their hosted payload, so they could actually detect things under the ground, which they weren't supposed to be doing, but they did as a result of not turning your engine off as you go across the surface of the moon. But we've also received from Chandrayaan, we sent the command that released their rover. We've supported Artemis and the CubeSats. That's another. I haven't got enough time to talk about the CubeSats. But Artemis, we supported Orion as it went around the moon as part of the work that we heard about Bockham did as well. And we had 6 of the CubeSats which we supported. We even actually supported 7 because one of them came to us and said if we could support them because they had problems. And the other, what are the highlights? And the other one, we very first started with Mars Express because I've worked on Mars Express from my very first job doing Mars. And so I asked if I could borrow Mars Express as a way of calibrating and commissioning the antenna, which in hindsight was a mistake because ESA wanted us to demonstrate that we could put a carrier up and then wait for the spacecraft to say, yes, that's fine. Then it said, right, put modulation up, and then the spacecraft said, yes, that's fine. And then we did a dummy command, except Mars at the time was 20 minutes away, so you put the carrier up, 20 minutes there, 20 minutes back, 40 minutes, yes, now turn the modulation on. And then when we actually sent the command, it was the longest 40 minutes of my entire life, waiting for it to go, yes, it's fine. So I wish I'd picked something closer, maybe like Gaia, which was only like a couple of seconds. But anyway, that's you live and learn. Right. So anyway, that hoping I'm getting across that the dullness means that you can do cool stuff, right? And what the cool stuff is trying to do is that we've got LunarNet. LunarNet is a collection of standards that's being brought together by JAXA, this is the Japanese Space Agency, ESA, and NASA, and they are bringing together a lot of the standards, including CCSDS. But as I mentioned earlier, CCSDS is not great at bringing everything together from a systems engineering perspective, and so putting it all together requires a bit of modification to some of the standards. And as I mentioned before, to get a modification or a new document through, you have to go through the interoperability testing. So you have to have 2 independent implementations of that. The other thing that LunarNet does that is sort of new for institutional is the addition of navigation. We had some great talks this morning about CubeSats. CubeSats, or even low Earth orbiting satellites, use GPS for their navigation, for their orbit determination, and so on. And to be honest, people expect to have that around the moon. And so the plan is to deploy a GPS Galileo-like system around the moon, use the comm satellites, put navigation payloads on there as well, but also use the GPS or Galileo from the Earth, and can you actually use those spacecraft as well? And there's experiments that's going on to demonstrate that you can actually receive the GPS from on the surface of the moon. All the stuff around the moon in orbit uses the CCSDS stuff because that's what it's designed for. We've got trunk lines back to the Earth, which will be using the CCSDS stuff. But on the surface, we're going to be using Wi-Fi and we're going to be using 3GPP. We're not going to be reinventing stuff that works perfectly well on the surfaces of planets. So again, how do you connect these terrestrial networks to the space network and then bring it all together and then ultimately have it all seamless? Now, LunarNet was based on Mars. It was actually based on Mars, what we should have done on Mars 25 years ago, but didn't, and did it badly. And so the idea is that actually MarsNet is going to be the transition of the work we've done in the lunar and then putting it to Mars. And there's a real push now to go to Mars. There's a change of direction from in NASA now that actually there's maybe boots on the moon is one thing, but boots on Mars is where we should be going. That's another conversation. But anyway, that's. But we want to try and keep everything the same as the moon from the proximity perspective. But obviously, you've got a difference between 40 million kilometers to 400,000 kilometers. Okay, so that's where we are. So the challenge is, which is the whole person. I'm going to have a drink before. The challenge is then, as I mentioned, and this is the purpose of the talk, is that we need a lot of modification to books. I did have 2 slides on all the modifications required, and I thought, oh no, you've had enough. You've had enough about standardization, and so I won't inflict that on you. But we have a list of things that we need to change, and there are things that we need implementations of. And one of the things that have been noticed by the institutions, so NASA and ESA, at these management councils, at these engineering councils, is that the amateur radio community have been using ESA standards, CCSDS standards and ETSI standards for a very long time, and you use them all the time, and you're very good at it, brilliant at it. And I've got an example. I've asked Daniel if I could show this. So Daniel has very kindly showed me. This allowed me to show the work that he did on Orion, where he's basically created a GNU radio plot. He's then received the signals, the OQPSK, and this was done using the Allen Array telescope, using GNU radio, and he actually decoded it. I believe he decoded it within about 2 days of it launching, or probably even earlier, without any prior knowledge of what it was. He was actually learning people, and the same with there's a lot of other examples, and I'm not going to bring out all those examples, but here is another one that Daniel did from a a telemetry perspective, which demonstrates that he's digested the books, he's digested the AOS books, he knows about idle frames. And if you read all of his blogs, and you read a lot of other blogs, and you read all the stuff on the internet, there's a lot of information and knowledge that you've accumulated to be able to decode and understand CCSDS protocols. So, and this is not going to notice with like NASA and ESA, and so this is what we've sort of come up with, is we have a real problem now with resources. A lot of this standardization sort of goes under the radar. It's completely essential, but it just doesn't get the required funding that's actually needed. It's very low compared to the projects. One of the things we're trying to do as an institution is get the projects to help with the development as well, and don't just expect them to be spoon-fed to them. But given that you guys have already been doing this, could you come and help us with like reviewing the standards? So if we gave you the early drafts, would you be able to review it? Would you be able to implement the prototypes that will allow us to standardize these things quicker, to publish these things quicker? And so ESA and I have sort of come up, ESA and Goonhilly and the UK Space Agency have come up with a pilot program. Could we potentially get a pilot program where we ask you to do, maybe we pick two, and we have picked two particular standards that we've done. One of them, as I mentioned, is the link layer one, and one of them is a navigation one. So one of them is a link layer control, so it could be done in software. The navigation one probably needs GNU radio or a radio system. So two completely different ones. Are there teams of people out here that could help us to do that and come up with prototypes if we were to give you those draft specifications early on? Goonhilly and ESA would very much help in that development. There is a small amount of funding to be able to do this, of which ESA have given, well, will do when we apply for it and we win the work. So we're not just going to throw you all the standards and then expect you to come back, but maybe if we work with the teams, come up with teams, we would then maybe host a meeting in Goonhilly, maybe early next year, where you could, if you were given the information now, could you produce something or give us some feedback by next year? Could you have come up with some prototypes? And what we were thinking of, if we just have this sort of friendly competition where we give teams all the information we need, all the help that they would do, and hopefully they're hosting you in Goonhilly and showing you around Goonhilly for a couple of days, and we'll pay for all that for you, and all expenses paid down to Cornwall. Is that something that we could offer? And then if it all works, if you've demonstrated that it does actually work and it is actually worthwhile, would you want to present that to the CCSDS team? So we would then, again, pay for the teams or members of the teams to go over to the next meeting, which is probably going to be in the US, maybe in Washington or California. So could we then pay for you to present all your work, all your feedback to these meetings and to these people who are then going to be publishing? So I would like I've got a few discussion points, and I want to leave the rest of the 15 minutes or so just to have this conversation. So first of all, is this something that you guys would be supportive of? And are you interested in helping the development of these standards? Would you be willing to participate? Is hosting something in Goonhilly sort of required? But I think that the key one is and we think this is, but I want to open this up to you guys, is a trip to the US where you present your findings, is that enough of a draw, or do you need more, or do you need less? Is the hosting stuff in Goonhilly, is that something that it would be exciting, or something else? What else would you do? So I think from so instead of going to the US, would be a cash prize be something that's of interest, or donation or whatever. And again, it's something that I'd like to actually have this open discussion now, because I don't know. I think it's a great opportunity, but I'm obviously wanting you guys to help. Bearing in mind we help you guys all the time. Just put that one in. But I just want to open it up to the floor, and I want to. Can we leave the next 10 minutes to actually finding out? So on that point, I will leave it open to a discussion. Thank you.
Well, I think, Matt, you deserve a round of applause for the detail covering on this thing. And I think I'm going to probably be running around fairly quickly around, because I'm sure everybody was saying, oh, God, no. Oh, yes, but we can't not do it.
Well, it's up to you. I just want to get this feedback. We think it's a good idea, but we're coming it from a completely institutional bubble, so please.
Any comments?
As a radio amateur with many years of experience, as a space system consultant with 30 years of experience, I say to myself, you're trying to do it on the cheap. Why don't you actually...
Yes, we are.
Well, you are.
Yeah,
That's
yeah,
right.
absolutely.
And at the end of the day, some of us are retired. Some of us aren't. And this is a topic which would take an awful lot of time for people to work on.
Absolutely.
So, that's it.
No, and I'm not hiding the fact. The whole purpose of this conversation is that the institutions don't have the money to do it, and it just delays the. Well, I know, but we've got 15 minutes, and I can't spend. I agree. It's dreadful, but that's where we are, and we know that you guys are involved in using the standards, and so it's just a genuine question.
Hi. Yeah, that sounds a fascinating opportunity. Could you mentioned a couple of items that you're looking for assistance with. I think you said the link layer and
Yes.
the navigation, which
Yes.
is you're talking about software, GNU radio, etc. Could you just give a bit more detail on the sort of types of things you may be looking for?
Sure. So currently around Mars, there's something called Proximity 1, which has a link establishment protocol, which basically the orbiter sends down a carrier, and there's a bit of state machine that configures the ground asset to start a communication session. That has now been taken out to be standalone and runs it, and the idea is that we put that around the moon. And so it can be, and so that's the link layer side. It's a very, not simple, but it's a link layer state machine that would do a communication. The navigation one is basically a replication of the GPS signal around the moon. So it's probably not likely to be able to be done without RF components. So it's more, the first one, the link layer one, is the software. Probably could be done with software, whereas the AFS with the augmented forward signal, which is the navigation one, is probably not going to be able to do in the software. But again, that's my opinion.
Any other comments?
Hi, maybe more comment. So to my experience, standards come as a result of some practical need when we have something already working, and then we want to standardize and make things compatible between different systems. You mentioned Mars. I don't know how many people in this room actually designed any Mars communications. Not me, for sure. So if you ask for some help with implementation, to what extent you can give some details on the actual practical challenges that you face? But sure, you already have some implementation of the link layer.
Yeah, as part of the work, we can have regular conversations about the practical issues around putting stuff around Mars, but a lot of the standards aren't specifically for locations. The proximity one is just, unfortunately, it's just only being used around Mars at the moment, and with the idea of translating it to the moon. So actually, some of the stuff that I showed with like Daniel's work, they're using the same types of framing, the same sort of coding. It's just this session control that's slightly different, and it's unique. So you don't necessarily need any prior knowledge of communication systems, just to have the general knowledge that you already have.
Any other questions? Thoughts, observations?
I'll put the Mars picture back on because it's probably. Oh, I won't. It's gone off.
Matt, Dave, GKQ, you gave an example of Daniel decoding from a live spacecraft. I think it's that sort of motivation that would get this work done rather than the theoretical. So if you could give examples of possibly where there might be something to receive or something that's achieved practically from doing this implementation, I think that would probably make your task in finding somebody to do it easier.
Okay, thank you. I mean, that's we're sort of in a chicken and egg situation because we need the documents ready for people to cut metal, and there aren't any spacecraft that will do these things. So it has to be done at a simulation level at this stage to get the documents through. So, but I take your point. I understand. It's yes, yes. So basically, one has to provide the one end of it, and then you come and test. It's like a reference point. Yeah, absolutely. Pat.
Hi, Matt. It's Patrick Wood. It's probably just a kind of a point, but would there be any influence from some of the large LEO constellations on orbiting the Earth that may want to have future ambitions? Probably I'll start with the Mars rather than the Moon, because knowing Starlink. So yes, I think it's a great idea asking AMSAT, but are there many other players that will influence that? And a sort of secondary question, which is navigation. There's a lot of question in the UK about PNT and backup methods for PNT. Does that play at all into that? Because there's a lot of discussion about space-based as well as terrestrial backup for PNT systems.
Yeah, I think the one thing that CCSGS and the institutional organisations fail miserably at is getting involvement with industrial partners. So SpaceX, Blue, all those players. And OneWeb, all those players that have got constellations, it's very difficult to get them involved. We are slowly trying, but it's very painful activity. So it's not want for trying, but we can't get those people engaged because we're driving sort of the science missions as opposed to the. But your point is right about Mars, where Starlink could just distribute something around Mars, and that would maybe motivate. And we are slowly engaging, but it's quite difficult. And the PNT one, I think there is a lot of need for UK PNT resilience and stuff, and actually this work could easily go into that, but it doesn't. It's what it's like where everyone's siloed, so we just need to make those connections across.
I'm just wondering, with the connection with ESA, whether the Iris Squared is a good opportunity for you to actually drive some of the standards, because there's a lot of work in terms of driving how Iris Squared will be architected and the ability to then look at how that would expand to Moon and Mars in the future.
Okay, thanks, Pat. Yeah, that's a good point. Thank you.
Any other observations, thoughts?
Hello there. Paul Drury. I normally deal with telecom standards, but variation to the standards, will you guys be managing that?
Yeah, so the process will still continue with the variation in the standards, but ultimately what I'd like to do in the long term is get people who actually use the standards like you guys and get them funded into the working group, so you become at the beginning of it. One of the ambitions within ESA is to have sort of a CCSGS reference frames. Sorry, I won't use frame. A reference system that allows people, as Dave mentioned, you could then plug into, and that might be managed by a prime, but that's a bit further down the line. So in this original pilot, that all the modifications have already been done. It just comes down to implementing it and then identify any technical errors within the documentation through the implementation of the standards.
Okay. Hi, Matt.
Hi.
Question from the internet, or actually a discussion going on the YouTube channel.
Okay. Excellent.
As a reward, could we have a hosted payload somewhere around the moon?
That's brilliant.
I think that a lot of people are looking for, instead of a demonstrator that has a theoretical background, some actual hardware.
Okay, so you could basically collect so it's like a barter system, which is what's used now between ESA and NASA and so on. So actually having a barter where you do some work and then collect up to enough credits, as it were, to get a payload around the moon. I think that's a brilliant idea. Sounds good. And then that goes back to the very first point about doing it on the cheap, which we are. But again, there's an opportunity here to actually get stuff around the moon because we can barter it off with other people. Yeah, I think that's brilliant. Brilliant idea. Thank you. I'm going to write that down before I forget.
Well, while you write that down, can I find any other questions?
Oh, come on.
Thank you, Matt. It's been great. I'm Dave Johnson, G4DPZ. I'm the ONSEC of AMSAT-UK, and I have to declare I have an interest in this as well because I work for Goon Hilly too.
I'm your boss, so I
all right. As far as the AMSAT, the two hats I wear, I would be very pleased for AMSAT to get involved in this.
You would?
And I'm putting it on the table that if you want a coordinator, I would do it.
Okay, perfect. Thank you.
And anyone else? Any hands up? Yeah.
Hi, Matt. It's Kieran, M0XTD. Doesn't this sound a little bit more like a research project that you could sponsor PhD students to do?
Absolutely. And I spoke to Chris Bridges, obviously, because we live around the corner from each other. So I've spoken to him about potentially for bringing in MSc students. This could be a project for MSc and bringing them in and then getting them exposed to the industry as well. So that's great for the career. So is anyone out there from university clubs, looking over here, so that would be ideal as well, because then exposing yourself to the industry and so on. So that is, I think, is a great idea. Again, trying to engage, try and have that engagement with universities is something that we're trying to do. It's always very difficult for institutions, but at the level like Goon Hilly and so on, and Pat has done it with SSTL, obviously with his connection with Surrey. So we are, from a company perspective, working very closely with universities, and so yeah, having it as part of an MSc course or an MSc project would be ideal. Yes.
And any other thoughts? Can't see any hands waving at the moment. No doubt you're happy to take any thoughts.
Absolutely, yeah,
after
I'll
the
be
event.
Here.
On that side as well, on that side. So,
well, thank you very much for your time, and thank you very much for listening.